Hello students, welcome to chapter 13 probability. Students, in probability today I continue our independent event, mutually exclusive event and exhausting event related our exercise 13.2 question number 6. In the sixth one, students, E and F event given and check that E and F are independent or not. So very easy. If P of E is give that 3 by 5, P of F 3 by 10 and E intersection F 1 by 5 and check that it is independent. So very easy, conditions you know that P of E into P of F 3 by 5 3 by 10 9 by 50 is not equal to that. Yes, is not equal to 1 by 5. So P of E intersection F is not equal to P of E intersection F. In short, we will write down show E and F are not independent event. Yes. Now over that, question 7. 7 is the students IMP for board exam related, because the given that there are two conditions, mutually exclusive and second independent event, defined value of P, where P of A given half, A union B given 3 by 5 and P of B given small p, and find out P in the two cases. My first case, if they are mutually exclusive events. So does mutually exclusive event means A intersection B, definitely you will take null set, and null set probability is known you, it is the 0. So my case is that given P of A union B, I will show PA plus PB minus P of A intersection B. P of A union B 3 by 5. P of A half. P of B small p. And here students null set. And null set probability, you know the very well, 0. So 3 by 5. Half plus P minus 0. So my P answer is a 3 by 5 minus half. 6 minus 5 by 10. Will do 1 by 10. 6 minus 5. Now in second conditions, if they are independent event, independent means PA into PB is A intersection B. So here probability of A intersection B, you will show PA into PB, and that's the known your half and P, which is P by 2. Property applies same as P of A union B. According to students, these are the given PA plus PB minus P of A intersection B. P of A union B, I have 3 by 5. P of A half. P of B small p, and that is small p by 2. That you know, this take left side. So 3 by 5 minus half. Here P by 2. So 6 minus 5 by 10 P by 2. It is 1 by 10 P by 2. So what's the P? 2 by 10, which is 1 by 5 only. And very easily we will done here students. This answer are happily. Now continue question number 8. 8 also very easy and practical numerical, give you in your book. Question number 8. Let A and B are independent, first of all given. If A and B are independent events and given that P of A 0.3, P of B 0.4, and asking that further 4 questions, P of A intersection B A union B. Third, A condition B. And fourth, P of B condition. There are 4 different questions asking in the questions. Very easy, students. First of all, independent event means A intersection B is multiply that, and here I will show that my first rule, PA into PB, it should be 0.3 into 0.4, 0.12. Here same, PA plus PB, P of A intersection B, and it is PA 0.3, 0.4, and intersection here define 0.12. So it should be 0.3 and 0.4, 0.7 means 70 minus 12. Yes, 60 to 58. Yes, 50, 60 and 70. Here you know that A intersection B upon P of B. So this A intersection B, I have known that one 0.12 and P of B 0.4. I mean 12 by 40. So 4 is 4 tens are, your answer is 0.3. And the last, similarly, P of B intersection A upon P of A. It's also known 0.12, and A I have 0.3, but I write down 30. 12 by 30. It is 3 fours, 3 tens, it is 0.4. I mean 0.40. Very easily and happily, students, this question 8 done here. Now I will go to 9th one. 9th also in the same way, easy to easiest I explain here, students. A and B are 2 events only, not given independent, only given events. A and B are 2 events, and the P of A 1/4, B 1/2, and A intersection B will be given 1/8, and find out probability of not A and not B. Yes, not A, not B. So it means A dash intersection B dash. Not A, not B. Intersection is and that. And here apply A union B whole dash. It is will do 1 minus P of. Not apply the independent property and not here given. And that will known PA plus PB minus P of A intersection B. In value put it, PA I have 1/4, PB half, and here students A intersection B also known 1/8. Take out the LCM overall. Here 8, 4 2s are 2 4s are and minus 1. 6 minus 1, 5. It is only 3/8. Now students continue. Question number 10. 10 also very easy. In the same way going, given that events A and B are such that, and asking independent or not, events of probability A half P of B is 7/12 and not A with or not B, not A, not B is a 1/4, and asking that checking A or B are independent or not. So does this meaning, first of all I will explain here. Not A means A dash or B dash is a 1/4, and here you calculate the further case. P of A intersection B whole dash 1 minus P of A intersection B, and define your A intersection B values. Probability of A intersection B 1 minus 1/4, it will be 3/4. Now check this answer is really to this product. Yes, so now checking P of A into P of B, it is 1/2, 7 by 12. It is 7 by 24. Check. This is exactly equal to 10. No. So P of A intersection B is never equals to P of A into P of B. That's why we will say A and B are not independent event, not independent events. And here students, easily this question is also done here. Now question number 11. 11 also as the same way I going. Given two independent events, yeah, clearly given students, if A and B are independent events and conditions are that P of A 0.3, P of B 0.6, and asking the further four questions. P of A 0.3, P of B 0.6. My first target, A and B. What the meaning for A and B? Intersection PA into PB, because the independent given. So these conditions wise I will apply that product rule. And PA I have 0.3, 6 3s are 18. Second, probability of A and not the B. Not the B means students B dash. Independent asking, so PA into P of B dash. And B dash have 1 minus PB. PA I have 0.3 and here 1 minus students P of B. So it is a 1 minus P of B 0.6. So 0.3 into 0.4. Your answer is 4 is 12. 0.12. Now third one. Third also very interesting. A or B. Probability of A or B. And A or B means union students. P of A union B. PA plus PB minus P of A intersection B. And that now I apply my answer PA 0.3, 0.6 and A intersection B known 0.18. Students, here you consider 30 and 60, 90. 0.90 minus 0.18. So 90 minus 18 is 80 and 80 minus 2, 0.72. Yes, 72 and 70, next 80 and 90. Now fourth one. Probability of asking in the fourth questions is that neither A nor B. Probability of neither A nor B. It means A dash and also B dash, both not covered to your answer parts. So P of A dash into P of B dash. 1 minus PA into 1 minus PB students. And that will be 1 minus P and 1 minus PB. Here you know 1 minus 0.3 and that PB is 0.6. It is 0.7. 0.4, 7 4s are 28, 0.28 is your answer. Now continue question number 12 students. 12 is also IMP for final exam. Exam related IMP questions. 12th one. Yes, that is also IMP. A dice is tossed thrice and find the probability of getting an odd number at least once. Question 12. A dice tossed 3 times means U1, U2, U3. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Either 1, 2, 3, 4, 5, 6. And your event A or target achieve getting an odd number. Yes, getting an odd number at least once. At least one means one time getting odd, either two time getting odd, either three time getting odd. This meaning, otherwise, this meaning I just write down this first, either second, either third. At least one means here we write down one time getting odd number, otherwise two times getting odd number, either third case there is three time getting odd numbers. Students, in this criteria, if you all three are defined, it's very lengthy. That's why I find out 1 minus no taking, I mean getting odd numbers. So probability of A, indirectly I will define here 1 minus probability of A dash. A dash means no getting odd number in all three tosses, and that's probability is very easy. Just here probability of A1 dash intersection A2 dash intersection A3 dash, and dash means getting odd number, it means even number. So here I side by side I will write down getting even number on a dice toss 2, 4, 6, and that probability is what? 3 by 6 if you one time toss then. So that's are the half and a half. We will define that P of A1 dash, P of A2 dash, P of A3 dash. It will be half 1 minus 1 by 8, which should be 7 by 8, and that's your answer to getting at least one times a odd number indirectly. 1 minus P of A dash taking no getting odd numbers, it means all times I taking even numbers. So that's an important question done here. Now 13. In a box contain 2 balls are randomly selected with replacement. Out of the 10 black and 8 are red balls. Out of that total I have 18, and 2 balls are select with replacement. Yes, 2 balls are select with replacement type students questions, and my question is that first probability of both balls are red balls. Students, both are red means first red, and with replacement means again you putting your ball selection in the box, again red balls. Your answer is done here. 4 2s are 9 2s are 4 2s are 9 2s are. So 16 by 81. Same second probability of here question is there. First ball is black. First ball is black and second ball is red with replacement. That's why selected ball you putting down again in the box. First ball is black, so here black select 10c1 18c1 and red 8c1 18c1. That's your students answer done. So 10 by 18, 8 by 18, 5 2s are 9 2s are, here 4 2s are 9 2s are, 20 by 81. And students, one more question number 3rd is a IMP asking, because there are one of the logical questions. give in the questions. Only logic, apply that third one. Probability of one of the ball is black and other is red. One more time checking. Question is that one times given one of them is black and other is red. Here one of the given means first second not given, so I will asking that first ball is black, second ball is red. Otherwise change that first ball is red but second ball is black. In this way you will select your answers. Now very easy. First is black, 10 out of 1. Now second is red, 8 out of 1. Otherwise, now first is red, so 8C1 and here 10C1, and you will define your answer 10 by 18, 8 by 18 plus 8 by 18, 10 by 18. You just cutting down there 5 by 9, 4 by 9 plus here 4 by 9, 5 by 9. So 5 4s are 20, 20 by 91, 9 9s are 81, 40 by 81. You will cover your answers. Now continue. Question number 14. Also as much as same as I explained. This is your independent related questions. Yes, 14 is IMP students. IMP for exam. 2 students probability specify problem calculate. Both are the independently. Probability of A solving the problem half, B solving the problem 1/3, and both are independent events. And first question asking, what is the probability to trying the problem is solved? Probability of the problem is solved. I mean both students combine problem solving. So probability of A solve, otherwise B solving. Otherwise means students union. So probability of A union B. It should be formula known. P of A plus P of B minus P of A intersection B. But that you know. Independent event. P of A I have half, 1/3, but here PA into PB. So it is your 1/2 plus 1/3. That 1/2 into 1/3, and you will take simple answer to 1 by 2, 1 by 3, 1 by 6, 3 to 1 by 6. LCM taking 6 and total 5 minus 1 4 by 6. It is 2/3, and my 2/3 is a probability. Asking to probability for solve these problems to combine both are if you solve. Now second also IMP. Exactly one of them solve the problem. Question 2. Probability of exactly one of them solve the problem. So very easy. Exactly one of them means either A solve then B not solve, but either A not solve then B solve the problem. So students, probability for A here win, B not win, so B dash. Otherwise A not solve but B is solving the problem. Both are calculated individually, I mean independent event. That's why students, I will show here both in multiple. PA into P of B dash, P of A dash into P of B, and P of A as it is. Here 1 minus P of B, same 1 minus P of A and value put it. P of A I have half, P of B 1/3, P of A half, P of B 1/3. So my answer is 1/2, 2/3, 3 minus 1. Same here, half, 1/3. So 2 plus 1, 3 2 is 6, 3/6, and 3/6. It should be answer is only 1. Now question 15. To verify given events are independent or not. Here checking to independent or not, one card is drawn, well separate pack of 52 cards. Which is the following cases are given, and you check that independent or not. Very interesting question. Students, first one, event E. The card drawn is spade. The card drawn is a spade. So how many spades cards? Only 13. Yes, 13 cards, and it should be probability 13/52, 1/4. Second, event F. The card drawn is an ace. The card drawn is an ace cards. So aces card, students, only 4 cards. So probability of F 4/52. And now event E intersection F. Both of you intersection find out. So spade and ace card. So the card drawn a spade of ace, and that only one card. So my probability is E intersection F 1/52. Now I will check to verify it's independent or not. So now probability of E intersection F. E I have 1/4, F is 1/13, 52, and yes, sure, it is same as to intersection F. That's why P of E intersection F, P of E into P of F. That's why you will show last. So E and F are independent events. Here, students, easily and happily this question is done. Now question second. Similarly, students, we going ahead. The second question. Event E. Given the card drawn. Yes, the card drawn is black. Only the black asking. It is only 13 cards. Probability of E will do 13/4, 52, 1/4. And next event F. The card drawn is a king. So this king card is total 4 cards. Only 4 cards are king. So probability of F 1/13. Now both mixing. So event E intersection F. The card drawn is a black king, and a black king only 1 card. So probability of E intersection F is 1 card by 52. Now checking probability of E into F is E 1/4, F 1/13, and check it is 1/52. According to that, here also we will show. So P of E into P of F is equal to P of E intersection F. You also verify that it is 1/52. It's same as to that. So that's why yes, E and F are independent events. Now third one. Similarly, event third. question 15, but third questions as much as same as I explained, only you define the elements and probability. So third one, event E. My third data given, the card drawn is a king or queen, is a king or the queen. So king have 4 cards, queen also 4, so indirectly 4 plus 4, it is 8 cards. So probability of E, 8 by 52, 4 2s are 13 4s are, it's the 2 by 13. Now event F. So this event F is a queen or jack. The card drawn is a queen or jack. Yes, one more time check, queen or jack. So here also students, queen are 4, jack also 4, total we have total 8 cards. And probability of F, 8 by 52, 2 by 13. Now also event E intersection F, and E intersection F, queen or king, queen or jack, it was only queen. This is a queen, I common, in the both common. So the card drawn is a queen, and queen only and only 4. So probability of E intersection F will be 4 by 52, 1 by 13. Now students, I will check to E intersection F. What's the E? 2 by 13, but F 2 by 13. So your answer is 4 by 169, and sure it is equal to? No. So P of E into P of F is not equal to P of E intersection F. That's why we'll do no. E and F are not independent event, not independent events. Yes students, here up to question 15 students, I will over that these parts and I will stop this video students, and after explaining in the next video I will continue this chapter students. Bye bye.